G'day viewers, I'm not sure if it's possible, but I'll see if I can remove these rivets on this NST and get the top off. See if I can fix the wires in here. As you can see, here's a fair bit of damage to the laminations of that transformer. Hopefully it hasn't expanded and damaged any windings. It's been sitting for way too long out in the weather. Yeah, it's a very unique NST. This is probably quite a rare one. Okay, viewers, I managed to get the top off this transformer. It was a bit of a brute force, but after tore that open and got this side off and just tapped it till it came off. Damaged it a little bit. A lot of asphalt now, chipped some of it off. There's a bit of wood there, and that's laying on the transformer. So that's what it would have been as a packer. So I've got to get to this standoff here. So I've got to dig out quite a bit of asphalt to get to that, see if the connections are. You've got to dig out all the asphalt around it, see if that's still connected. But hopefully that's all it is. If I can fix that wire up, hopefully this may work again. Okay viewers, I got that little wooden spacer off, and the laminations are even rusty up here. Some moisture's been drawn up into the laminations, moisture's gone up and just going all through this. That's one rusty NST, which is unfortunate. This is quite a rare one. I don't think anyone's ever seen an NST quite like this before. I think the Nielsen here, Oliver J. Nielsen and Company. I think it's the same Nielsen that made those EMS 2600 and 2100 push button electricity meters. It says here switchgear manufacturers. Then they went into the metering business. So quite a bit of a rare bit of Aussie history. This was actually made in Australia. They were based in Melbourne, Adelaide and Sydney. There you go, 3 kV at 100 milliamps. This would have been quite nice for all sorts of experiments, but it's unfortunate that this the weather's got into it, and you can see it's just all the moisture has gone straight through it. All that bulging is probably not good in it either, so hopefully it hasn't actually ripped any windings inside the core. If I can get to the connections, especially here, or even here, one of these two, I should be able to carefully just get the asphalt out of here, extract it and see if we've got a connection. It's messy stuff, this asphalt. Okay viewers, after some careful extraction, I've got a winding here. I don't know if that's actually coming off through the winding of the transformer or going off that standoff, but let's ohm it and do a continuity test and see where that's coming from. Hopefully it's coming from the transformer winding. Let's see. Now viewers, I'll set this down here. You should be able to set up multimeter. Turn that light off. Alright, ready to go. Let's ohm this continuity of this winding. Okay, that's going to the standoff. Alright. Check again. Yep, that wire is coming off from the standoff, so that was going through there, and that was up. It was followed up, but it kind of went back through here somewhere. I'm going to have to chisel carefully around here, this area here, and see if I can actually find the between here and here somewhere where it's actually connects to the winding and the transformer. So that's hopefully this is going to repair it. It'd be nice to have this working again. Okay, viewers, I chipped some more asphalt off this part of the core, and sure enough, another winding's exposed. Maybe that been around there, around, followed up under here and then went to the standoff. So I don't know how that would have worked, because that would have shot it directly to the core, or the laminations. You can see the bloody bulge in it. They're not really laminations anymore, it's all one solid lump of rust. Shame the rust bit me to it. This would have been a nice rarity to have, especially something like this. Anyway, let's ohm this and see what happens. The camera back up here, the multimeter. Alright, continuity. What am I doing here? There we go. Had the wrong setting on. Looks about the same size as this isolation transformer that the meter's sitting on. The looks like the same physical size. Between ground and that winding there, don't know. Let's give it an ohm up, let's see what happens. Okay, standoff off ground and that winding. Can't get a hold of this bloody thing straight. So low ohms, so it must be a winding there. It's not a very high reading, so let's give it a wire it up and see what happens. The transformer itself is not going to run very efficiently when it's that rusty, unfortunately, but let's see if that's actually the output off the secondary. So you can see the secondary is that wide. Then here, the little primary is in here. You can see the end of the primary there, and there's a primary. There's like a little shunt there. There's a secondary. It's like a mott, has a shunt in the middle. The thickness of that wire is about, you know, it's a lot thicker than the MOT secondary anyway, so let's see if this actually works. Okay viewers, let's see if this works. Works on 0 power on. 240 volts. Nah, it's dead. Damn it. Okay, I should investigate more. Alright, let's see what else I can find. Maybe I'll see if there's anything in here that's gotten damaged. Maybe the primer's disconnected. Okay viewers, unfortunately these laminations just all falling out. I think this transformer's stuffed. You can see how much swelling that's been going on in here. All that swelling from the iron might have torn the windings. So these are all connected. This and here just snapped off as I was getting the asphalt out. This transformer's all falling apart. It's all mylar and rag in there, and those windings all insulating. If I can get the copper out and maybe get some new laminations or something, maybe I'll fix it, but it's just too much involved. The rust problem's just too far gone. All that swelling is just yeah, damaged it. So I think I'm just gonna have to get the just salvage these standoffs. I keep breaking it apart and salvage these standoffs, and that'll be it. It's a shame this rust problem was so bad. Otherwise, if it wasn't so bad, the bloody rusted, this may have worked. Because they're all still connected, so it's totally dead, I'm afraid. So let's get these standoffs off, and that'll be it. I've gotten something useful out of this. Okay viewers, I did aim the windings. I found the other connections to the HT, the high voltage output winding. It's about the same thickness as an MOT secondary, so it's pretty much the same as an MOT, just at a big shunt. There's a lot of corrosion in these windings. A lot of corrosion. I did some aiming, sure enough, somewhere in this winding here it's open. Don't know where, but the primary wasn't very good either, so unfortunately the corrosion was so bad, it's bloody, yeah, you can see there. Unfortunate. Such a rare NST, and the bloody Mother Nature bet me to it. But I got some good goodies off it. Because I got a good standoff. The terminal block got a bit chipped unfortunately, but I can re-glue, super glue that. This will come in handy, and this will definitely come in handy. These are very rare. I could still use that, so I can make another enclosure and stick it MOT or something, ballast it, so I definitely got some goodies off that one. Anyway viewers, that'll be enough for now, so thanks for watching.